Hey everybody, I'm Cam Knight. I was design lead for Project 1, the first half of the class, and I'm now lovingly referred to as that other guy for Project 2. I didn't have one of the main three roles, so I'll be putting the video presentation together for our assignment. Starting us off is our team lead, Silas. Take it away, Silas.
Hi, I'm going to tell you a little bit about our app that we made for mobile app programming in the spring of 2023. I'm Silas Barber and I served as the team lead for part two of this assignment. And I'm going to go through the class structure of the project and then show you a bit of the app. This is the class diagram that I made at the beginning of the process for this part two of the assignment. At the top left, we have that little cloud representing our app, and that shows that the app interacts with two view models to manipulate the app's data. So there's two view model repository pairs, one for the user on the top and one for the weather on the bottom, and those both are stored in a single database on the right side of this diagram. And these are all the classes that are necessary to make that work. I'm going to go to the app now. Here I am in our app. At the top there's a bar showing some info about the user, and in the middle you see our main page, and here you can see and access all the modules in our app. I'm going to go to the profile module. This shows all the info about the user, and we can edit it here. So if I tap on the user's name, I can change that. And you can see that that change is reflected in the top bar. If I rotate the screen here, that info is preserved. I can edit the number quantities here without typing anything, just with these number pickers. I can change the sex with a drop down. And once again, those changes are reflected at the top in that bar. If I tap on the location field, the location gets refreshed, and that gets a location based on GPS data. In this case, the emulator thinks it's in Mountain View, California. I'm going to tap on the empty profile picture at the top of the profile module. That'll take us to the camera to take a profile picture for our user. Now that profile picture is saved.
That's all for the profile module. Now Preston Hales, our Project 2 test lead, will discuss the BMR module of the app.
I'm going to be talking about the BMR module for our app. So the first thing to talk about is how we calculate the BMR. So we use this formula right here. It's different based on the user, depending on if they're male or female. And we also got it from this website. That's pretty much it. Nothing too crazy. And then we also calculate their activity level based on this criteria, where based on how many calories they burn per week, doing workouts will determine their activity level. And there's also estimations for the user's daily caloric intake based on both their BMR as well as their exercises. And so I'll show that all off here in the app. So right now our user has daily caloric intake of 1,759 calories per day, and that's showing up here on the nav bar as well as down here. And because of that, they're only burning 300 calories per week for their exercise, and so they have a sedentary activity level. But if we increase their intensity for workouts, for example, their activity level will be increased to lightly active in this case, because now they're burning 900 calories per week. We can also increase or decrease how many workouts they do per week. That also factors into how many calories they're burning, as well as how long they're working out for. So now they're considered active. And right here at the bottom, we also have the estimated values for their daily caloric intake based on activity levels. So for someone that's active, they would be burning somewhere around 2,037 calories per day, which is what this user is doing. And so that's why they're considered active. If they increase their calories per day to somewhere around 2,287, they would be considered very active. And so the user could use this to kind of see where they're at how many calories they need to continue to burn in order to reach maybe a certain goal that they have. So yeah, that's pretty much our BMR calculator.
Hello, my name is Jacob Bullard, and my role for the team here was to be available as needed and intern with these guys, with the Teal team. I was assigned to present the weather module, so I'd like to go ahead and do that. The weather module is going to pull data from openweathermap.org. By default, it's going to just use the user's location. It integrates with the hikes module in the sense that when the user enters information into the hikes page, it will transfer over to the weather module and actually show the weather for the location of that hike. So I'd like to demonstrate that for you and show you exactly how that works. As you can see here on the Android app, by default, it's just going to show the location of the user and the weather there. And this is going to be defaulted for the user wherever this Android app is. So this looks like it appears to be in Mountain View, California. Now, if we go to the hikes module here and say we wanted to change the state here to Utah, and let's go ahead and submit those location changes. You'll see that this is going to change. It's going to pick a city here. And if we go to the weather module, it will actually update here and show that weather here. So thank you very much.
Hey, now it's my turn again. Again, I'm Cam, design lead for phase 1 and the other guy for phase 2. I'll be presenting about our last module, the user location and hikes module. Alright, now before we get into the emulator and demonstrate in the app, I'm going to talk a little bit about the implementation of the features of this module. The profile, weather, and hikes module all use Android location services to get information about the device's GPS location. And then the Android geocoder class uses that device location information to apply an address to that GPS location. We also use the geocoder in the hikes module to take a user text entry and generate location data from it to include the longitude and latitude, as well as any unentered fields that the user may have wanted the app to autocomplete. Let's go ahead and demonstrate in the app. Okay, here we are in the emulator. We've got our default address filled out here. I'm going to go ahead and change it to be something else. I'll just go ahead and try Utah. I'm going to pick Salt Lake. And then put in, let's say, 27 North Orange Street. Now, the zip code is wrong, but let's see if it can fix it for us. There we go. So it killed the 27 North, but it did autocorrect the zip code. Just like I was talking about earlier, our geocoder was successful. I had to click this Submit Location Changes button for it to input what I had typed into these text boxes. And I can always use this Use Current GPS Location button to go back to the GPS location rather than the text entry location. It'll take me back to that Mountain View, California version. After we're done entering our location in here, I'll go, there's this Hikes Near Me button. I can click on that and it opens up Google Maps. And it's taking me straight to California, that address that it had, and it points out all the hikes around that address. Cool, now we're going to move on to demonstrating the app in tablet mode. Alright, here's the emulator of a Nexus 9, and this is our app in it. We can go to all the pages. Some of the pages don't display quite right, but we have it on a scroll, so you can scroll through it. It does display nice and wide, as well as, all your text is real nice and big. Makes it really easy to edit all of these values. Again, this is a new device, so it doesn't have the location yet. Let's go ahead and use our GPS location. Cool, got it. And then the weather API populates. Very nice. Mr. Bob Ross here, all nice and happy, working on the tablet mode. Hey, and that wraps up our presentation. Thank you guys so much for watching. Had a really good time this spring 2023 mobile app dev class, and see you next time.